Okay, so one of the other things you need to be able to do with Taylor polynomials is if you're given the Taylor polynomial, find a specific function value. So they might ask you to find, like if you're given a polynomial, find the value for the first derivative or find the value for the third derivative. So I just wanted to remind you of a couple things. Over here, for either the Taylor polynomial or the Maclaurin polynomial, the number that's by itself, it doesn't have an x, it doesn't have an x squared, anything like that. That's just whatever your function value is. So when we look over here, we are given this Taylor polynomial, and we want to find f of 0. So that corresponds to just like whatever the function value is. So you're looking for whatever doesn't have a variable with it. This doesn't have a variable with it, so that means f of 0 is equal to 7. Easy. It's just as easy with your first derivative. When you look at the first derivative in the Taylor formula or in the Maclaurin formula, it doesn't matter. It's not divided by anything, it's just whatever is in front of x to the first power. So when we look over here, when we're trying to find f prime of 0, we want to see what is just with x. So we look at this term. The thing that's with x is -2, so that means f prime of 0 is -2. Now once you get past the function value or the first derivative, we always start having it's divided by something. So if they ask you about second, third, fourth, whatever derivative past that, it's not as simple as just what number is in front of it. You've got to think through, it was divided by something, so what was it before that point? So when we do second derivative, we want to look at the x squared part. So what I would suggest doing is looking over here, since we know this is centered at 0. In general, the second term looks like f double prime of 0, x squared over 2 factorial. When we compare it to specifically what we see in this problem, it's equal to 13x squared. So now we want to start solving for your f double prime. So there's an x squared on both sides, so those are going to divide out. So you're left with f double prime of 0 over 2 factorial is just 2 equals 13. So to solve for f double prime of 0, we just multiply by 2, and that's going to give us 26. That looks like a -26. Let me fix that. Okay. We're going to do the exact same thing with the third derivative. So we look at the x cubed term, and we think about, in general, what it would look like. So in general, it would be f triple prime of 0, x cubed over 3 factorial. Specifically for this problem, it's -1/2 x cubed. So the same thing happens as it did last time. There's an x cubed on both sides, so those are going to divide out. Then we get f triple prime of 0. 3 factorial means 3 times 2 times 1, so that gives us 6 equals -1/2. So we want to get rid of the 6, so we can get f triple prime of 0 by itself. So those are going to divide out. So now f triple prime of 0 is -1/2 times 6, which is going to give us -3. So if you're given the Taylor polynomial and you need to find specific values, remember over here, if you're looking for like the first derivative or the function value, it's really easy. It's just whatever you see in the polynomial. Once you get to the second derivative, you need to think about in general what it looks like and then specifically what you see so that you can solve for whatever you're asked for.